Good afternoon, everybody. Welcome to this live virtual tour of Research Vessel Investigator for National Science Week in 2020. I'm Dr. Ben, and I'm joined today by David, our vessel manager, and Megan, who is one of our voyage operations manager. Welcome to you both.
Hi.
Thank you.
Hi.
This afternoon, we're going to take you guys on a bit of a whistle-stop tour of Research Vessel Investigator while we're in its home port here in Hobart for National Science Week in 2020. So when we're live, you guys feel free to jump in with any questions that you might have for us. You can type them into the comments and we'll do our best to get them addressed for you. As we're cruising along today, as you can imagine, this is a pretty big ship. There's a lot of metal, so we may have the odd dropout or two as we're going up and down stairwells. That should rectify itself in 5 or 10 seconds or so bear with us and we'll be back online fairly shortly. And also, as we're going along today, just to safeguard the health of everybody on board, the ship's currently operating under some COVID-19 protocols, so we'll be following those while we're on board as well. So, we are here on board Investigator today. Investigator is Australia's only dedicated offshore marine science vessel, which surprises a lot of people because Australia has the third biggest marine territory of any country on Earth. So it's a huge big area, and Investigator is the only dedicated research vessel that we have to cover that whole domain. So that means this ship has to be able to do marine science and atmospheric science anywhere from the edge of the sea ice right down in Antarctica up to the equator, the Pacific Ocean, the Indian Ocean either side. There's a lot of ground to cover. So we're on board today, on board our 94-metre vessel, 18 metres across the beam, and because today's tour is all about what is above the waterline, we're actually starting up here on Deck 7, which is the tallest accessible spot on the ship. Investigator actually has 10 internal decks. There are 3 below the waterline and then 7 above, which makes 10 all up, and we're joining you live from Deck 7 up here on a glorious Hobart afternoon. So what we're going to have a look at around here is, I guess, some of the atmospheric science that we do. A lot of people don't realise that when you do marine science, you really have to also understand the atmosphere as well. And Investigator has a lot of capabilities to help us understand the atmosphere that exists right around the Australian continent. So one of the most obvious and unique things about Investigator is, if we spin around here and have a look behind us, is way up top this giant soccer ball is what it looks like. This is our weather radar. So Investigator is one of the few research vessels in the world that actually has a fully blown meteorological research radar on top. And you can imagine that a piece of equipment like a weather radar, which relies on a constant line of sight to the horizon to collect measurements of rainfall, you can probably appreciate there's some difficulties actually in getting something like that installed on a moving platform that's constantly rolling around when it's at sea. So this radar is pretty similar to weather radars that you might be familiar with that the Bureau of Meteorology runs, for example, on shore. It's a dual polarization Doppler radar. It sends out 800 pulses every second, and that enables us to look 150 kilometres around the vessel in a radius and 20 k's up into the atmosphere. And we're looking for things like the size, the number, the shape, the rate of fall of precipitation. So that might be rain, that might be snow, it could even be hail. And as I said, this is a fairly similar setup to what the Bureau of Meteorology has on shore, and we've actually used this recently in the last 12 months or so to actually help improve some of the readings that the Bureau gets off their weather radars. A lot of the radars that we have around Australia actually has one of the biggest radar networks. We have about 60 onshore radars right around the Australian continent. A lot of those are getting pretty old now, and this one behind us here is much newer, so therefore it's more accurate. So what we've been able to do in a couple of instances is actually, when we're close inshore, we park the vessel offshore inside that 150 kilometre radar sweep. So our radar and the shore-based radar are overlapping with each other. We basically sit there and park up, wait for it to rain. We take our observations, the Bureau takes theirs, and then we provide that data to them to ultimately help them improve their observations, which ultimately helps you guys when you pull out your weather app on your smartphone to determine if you need a brolly for the day. So there's some science there that's helping you guys out. If we spin around behind us here, we have some smaller golf balls, not quite as big as a soccer ball. These are our little golf balls. There's one on either side, and these are our satellites. These are our VSATs. So as you can imagine, on a vessel this complicated, there's an awful lot of information, an awful lot of data that gets collected. We can't just house all that data on board. We need to send it back to shore all the time. So our satellite is enabling us to do that. And it's also really important for I guess, the personnel on board as well. So the ship is enabled with Wi-Fi and pretty good communications on shore. So Megan, when you are at sea as a voyage manager, obviously one of your roles is to make sure that, you know, people, all the voyage participants, their health and safety and their well-being is good and they're kind of looking after themselves. How important is it to have something like this, to have good communications back to shore for people?
Hugely important. You've got to remember there can be up to 60 people on the ship at a time, and it can be at sea for up to 60 days in really remote locations, so deep in the Southern Ocean. So yeah, there's definitely a sense that people can feel isolated, but this is one of the big ways to break that down, in that you can just WhatsApp your family, email people, let them know how you're going and see how your family's going, and let them know the kind of things you get up to on the ship as well. So it's a massive benefit, it really is. Certainly.
So kind of gone are the days of just relying on telex or emails to send off once or twice a day. Now you can post photos on your social media for your families and pick up the phone and have a chat to them, which is something really important. What we might do now is we might actually pop inside and we'll have a look at the observation deck on the way down to the bridge. So we're still on deck 7 here, the same level. Here we are about 23 metres above the waterline, so nice and high. And up here, what we have is the dedicated observation lounge. So this area here is purpose-built for observations of wildlife, so mostly seabirds and marine mammals such as whales. So we've got a 270-degree view right around the vessel here. On a clear day, the horizon is 18 kilometres away. So if there's any form of whale or anything out there, we're going to be able to spot it, which is fantastic. It's one of my favourite spots to hang out on the ship because the view's good, and also you get to see whales, and who doesn't want to see whales? I kind of talked before when we were chatting about the satellite dish about all of the information that this vessel collects. And a lot of that is collected every time we go to sea, regardless of what the primary objective of the voyage might be. And everything's interconnected here, so when we have our teams on board doing our observations for seabirds and wildlife, they can hook into the ship's computer system here. Whenever they log an observation of a whale, we can kind of automatically populate other information around the environment. So we've seen a whale here, and then we log that sighting, and then we get the sea surface temperature, we get the salinity, we get the nutrient levels, we get the dissolved oxygen, all that information that I guess helps us greater understand the observations that we might be seeing. So having that interconnectedness is really important on a vessel like this. So what we might do now is we might wander down to the bridge and we'll have a chat to one of the bridge crew. And as we're going, I think we've got a question we might take as well. What have we got there, Meg?
Indeed. So we've got a question, a bit of a curly one. Can the radar detect other objects in the atmosphere or just precipitation?
So it would be able to detect other objects in the atmosphere as well. So David, we would have a navigation radar downstairs on the bridge that we will have a look at. But really for the research purposes, what we're interested in is those particles in the atmosphere, such as precipitation and those kind of things. Whereas the navigation radar would be looking at ships and aircraft and those kind of things. So, welcome to the down one level now. This is obviously where the ship gets driven from. It's an open bridge, which means that during a voyage, most of the time it's open and anyone can come up here, which is great. It's a little bit different than if you've been on a cruise boat or a ferry where, you know, the captain is kind of behind a locked door. Anybody on board can come and have a chat to these guys. And we have with us Sam,
hey guys,
who is one of the bridge crew. So Sam, you're part of the bridge crew on Investigator. What is your role on board the ship?
So typically I'm on board as a third officer. So some of my responsibilities include driving the ship or keeping a navigational watch for 8 hours a day. Additionally, I'm responsible for things like the firefighting systems, life-saving appliances, and when we don't have a doctor on board, also all of the medical first aid treatment.
Okay, so what's a typical day at sea for you, or is there no such thing as a typical day?
So we try to keep a routine as best we can. So typically there are 3 deck officers who we work a 4 on 8 off rotation up here. So my day normally starts at 8 AM and I'm on watch up here until midday. Have a couple hours to do the other checks and things I need to do after midday, get some sleep, and then I start watch again at 8 PM and through till midnight, and then we start again.
And that can be up for 60 days if it's a big long voyage. So Investigator is obviously very different than other ships in the kind of work that it does. How is it different for you guys up here on the bridge compared to a standard ship like a ferry or a cargo ship?
Yeah, so a lot of other ships, very much sailing from point A to point B. They're taking cargo, people, whatever it may be. Up here, because of the nature of the science and the very fluid systems that we use for determining what it is we're going to be doing at any point in time, it's an ever-changing day for us.
They're going to be flexible?
Very flexible, and it's a lot of making sure that we keep everyone on board safe. For us is one of the main role we do up here, is ensuring that everyone's safe at all times. We're not putting the ship at risk or anyone else on board at risk.
Fantastic. And one of the unique things about Investigator is it's the first, what we call paperless ship in Australia, or one of the first paperless ships in Australia. What does that mean?
Well, I really wish it meant that we didn't use any paper. But what it actually means is that we don't have any paper charts.
Okay, so what have we got? How do we navigate?
So all of our navigation is done via this system here, which is an ECDIS unit. And ECDIS stands for Electronic Chart and Display Information System. So this uses our GPS feed, and it gives us a lovely little representation here of what our ship looks like. And you can see alongside here we are at Sullivan's Wharf, or Prince's Wharf, sorry. And we can use this to navigate and plot our courses and tracks and everything all the way around Australia and around the world as we travel.
So that has the whole world loaded into it. We can go anywhere.
We can, depending on how much fuel we have on board, of course.
We've actually just had a question come through around driving the vessel, and that was, what is the tightest turn the ship can make?
Technically, we can turn within our own length without any dramas. So we're 96 metres long, and we can effectively spin the boat around without actually moving forward at all.
So there you go. That's pretty impressive. So we're kind of talking about manoeuvrability and so on. I guess doing scientific operations at sea requires the vessel to be quite manoeuvrable. How do we achieve that, and what special systems do we have to enable us to deploy equipment and those kind of things?
Yeah, sure. So the vessel's classified as a DP1, or a Dynamic Positioning 1 vessel, which means that we've got the equipment in order to keep the vessel on a set point of the Earth, and then we can safely deploy the equipment. So we do that using this computer over here, which is our DP system. So this uses a combination of the ship's 2 propellers, 2 rudders, and we have a drop-down 360-degree azimuth bow thruster, which we can use to keep us in position. Now, we can set that up to allow the computer to do a lot of magical driving for us, or my personal favourite is we can drive the entire ship off this little joystick here. So all those years of PlayStation training I had really came to fruition.
That's I guess okay. So the tip for any kids watching out there is, despite what your parents might tell you, time spent on the PlayStation or the Nintendo can be put to good use later in life, which is good to know. So how does that system cope with wind and swell? Like how good is it at holding us in the little position that we need to be?
Yeah, sure. So like every system, it has its limits. It comes down to the operator of knowing to what they are. As a general rule, it will keep us in a pretty good position in 20 to 25 knots of wind and up to about 3 metres worth of swell.
Okay.
From there, though, we can fine-tune it by driving it, I guess, personally, to ensure that we can maximise the amount of science time before we will pull the pin in order to keep all the equipment and people safe.
Sure. And speaking of driving it, as we kind of walked in, people may have noticed that there's no big wooden steering wheel anymore.
No, I was very disappointed about that, man.
How do we drive it? What's the story down here?
So this ship is quite simple in how it's driven. We have this lovely little knob here, drives one rudder, and this lovely one over here drives the other one. We can drive them synchronous together, so effectively by turning one, I'm turning both. And that is how we would drive this the ship in hand steering. Our propulsion is done by these 2 bad boys here. Effectively push them ahead to go ahead, push them stern to go astern, just like any other boat that you may have been on if you have one yourself. So we have 2 electric propulsion motors, so they are directly attached to 2 fixed pitch propellers, and being electric drive, we can load them up or take the load off very, very quickly, which allows the ship to be very manoeuvrable.
Okay, and what about like autopilot? I assume you guys aren't sitting here spinning these little dials all the time?
No, we're not. That would be rather time consuming, a bit tedious for us. No, so what we can do, the beauty about our ECDIS system is we can we have an integrated autopilot in that system, so that allows us to effectively line the ship up on a heading, and it will follow that. put in a fixed course for it to follow, or we can put it in to follow a designated track, which is very helpful when we're doing things like swath mapping surveys and those types of things.
Perfect. And we have actually had a question come through around fuel. How long does it take us to refuel the ship when we're in port?
So we normally allow a day. So it depends where we are in the world and what type of system we're using for bunkering. But pretty much it is the better part of a day's exercise in order to take all of the diesel in.
That's full, and that'll be 60 days worth of fuel basically for us.
Yeah, pretty much.
Okay.
So we can take about 620 cubic metres worth of diesel.
And what's our range on that? How far can we go on that?
It varies. Last long trip we did, we cracked 10,000 nautical miles.
10,000. So we can get to some fairly far-flung corners of the Australian marine territory.
Absolutely,
on that area. Yeah. Okay, that's fantastic. I think what we might do now is keep heading on downstairs. Thanks, Sam, for his time.
No worries,
Thank you very much. And we'll keep sending those questions through.
Right. Thanks, guys. Cheers.
All right, let's head on down. While we're doing that, we'll see if we've got any other questions coming through. But I might ask Megan about how we operate when we're at sea as far as people's shifts. Obviously, Sam was just saying then that he does these 8-hour watches. What does everyone else do on board?
So, yeah, the interesting thing with the ship is that it does operate 24/7, so no weekends, no public holidays on board. Normally people work 2 12-hour shifts, so they would work from 2 a.m. to 2 p.m. and then another shift from 2 p.m. to 2 a.m. So it is a bit of an adjustment, but yeah, that means we can do 24-hour science operations on board.
So we've got to make the most of each time we're out at sea, because obviously it's very valuable and we need to get as much work done as we possibly can.
Yep.
So we've just popped outside on, as you can see, is a glorious Hobart afternoon. So we're obviously looking forward on the ship now, down here. So this is the foredeck, and what we've got in front of us is the foremast of Investigator here. And it's actually quite a complicated foremast. There's a lot of pieces of equipment on it. I mentioned before that we collect a lot of information, a lot of data every time we go to sea, and that's what we call underway sampling. And part of that is the aerosol sampling, the atmospheric sampling. So on the foremast, you can probably see the anemometers spinning around, so that's to kind of look at the meteorology and the weather. But further down, we actually have some air intakes, and basically as the ship is driving along, we're constantly pumping air in through that foremast, which is hollow. It gets pumped down, and underneath the forecastle at the front there, underneath the floor, is actually a laboratory, an aerosol sampling laboratory. So that air gets pumped in, and then we're sampling the air basically. So we're looking for the atmospheric properties, so things like the quality of the air, trace gases such as CO2, methane, nitrous oxide, aerosols, things called cloud condensation nuclei, which actually help form clouds above the ocean, and things like radon, and radon is actually a signature for air that's come off the continent. So we can start to get a better understanding of the atmospheric properties above the oceans as well. So it's pretty neat to be able to constantly sample that. And when you're out at sea, out in the middle of the ocean, you can actually, if the wind's blowing in the right direction, you can actually tell that there's a ship on the horizon before you can see it, because you can pick up the fumes that are coming from that vessel. Also, if you have a look down a little bit further, the foredeck's pretty clear at the moment. You can see we've got these yellow tabs down here, and these are actually so that we can put containerized laboratories on board as well. So the ship already has an awful lot of laboratories on board, but we can put on specialized container laboratories. So, Megan, what kind of container laboratories would we want to put on board this ship?
We've had a whole range. So the Marine National Facility have their own set of container laboratories, and then we also have users bring on their own laboratories, and it's really around what you mentioned before, just getting as much science as we can on the ship. So we've got a few general purpose labs on the ship, but then our container laboratories just increase our versatility. So we have a laboratory for storing hazardous materials, so chemicals on board the ship to store them safely away from people. We've got another laboratory where we do isotope work, again to keep that safe and separate from the rest of the work on the ship. We've had the airbox on board, which is an entire shipping container fitted with atmospheric instruments collecting data non-stop. So it really just helps us get the most science we can out of voyages.
And things like trace metal analysis, one of the things that we often want to try and understand is some of the chemicals and the nutrients in the ocean, and things like iron are a big part of that, and you can imagine what we're trying to measure is tiny amounts of iron, and the risk for contamination on 94 metres worth of metal is very high, so we can put on specialised, really clean containers so that when we do that work, we're pretty sure of the results that we're going to get. I might just spin around before we head downstairs and have a look at what's behind us here. I'm going to ask a question of David. We have this big black writing on board the ship which says IMO and then a number. David, what is IMO?
IMO stands for the International Maritime Organization, which is the global body that looks after safe shipping operations. This is actually the vessel's registration number, so essentially like your license plate number for any car.
And every ship has one of these?
Every ship has one of these.
So there you go, that's us. So I'm assuming it's a bit different than a license plate. No one's going to get you in trouble at sea and ring in to the police what your license plate number is?
Well, actually, it is used as an identification number. Okay. So any type of operations or incidents that are considered untoward, someone can actually call in.
There you go. We'll make sure we behave ourselves.
Well,
All right.
Always do.
We always do. We're going to head further down and have a look at the back deck. And while we do that, we'll take some more questions as we're heading on down, if there are any. I think I've got some that have come through a little bit earlier. So one of them was around some of the interesting and strange things that we found at depth in the ocean. You kind of hear that saying that we know more about the surface of the moon than the depths of the ocean, and that is absolutely true. Around 25% of Australia's marine territory has been mapped to modern standards, so for about 3/4 of it we don't have any clue what's out there. It could be anything. And each time we send the ship to sea, we are mapping and we're looking to see what's down there. So there's interesting things that we've discovered as far as some of the geological features like sea mounts, and we discovered undersea mountains that might be 3,000 metres tall. It's pretty amazing to think that there could be a 3,000 metre mountain that we didn't know existed until 1 or 2 years ago. And then also the marine life too. And some of the stuff that lives down there is incredible. So we found things like whale skulls that have been full of zombie worms that are eating out the carcass. Things like peanut worms. One of my favourites was on a voyage that we did looking in the deep ocean. Herds of something called sea pigs, which are similar to deep sea cucumbers, I guess, in a way. These little sea pigs are actually, their bodies are filled with water and they kind of crawl along on the sea floor in these big herds. It's really cool. And there's all sorts of weird and wonderful things down there. Lots of bioluminescence, so lots of animals that create their own light so they can see and attract food. So there's all sorts of amazing things down there. So we're just going to keep on heading down now. What we can see down below us here is the main deck, so we're just above the waterline down here, and this is where we do the majority of our science operations from if we're deploying equipment from the vessel. So the back deck is a nice big open area and enables us lots of space to manoeuvre equipment and get everything deployed. So we're going to have a bit of a look around some of this stuff here. So I've got a couple of questions maybe for David over here. So you can probably see behind us we have this enormous, what we call the A-frame. You can see up there. What are we using the A-frame for?
Yeah.
What does it do?
So the A-frame is used for most of our deployments and captures of our scientific equipment. Every piece of equipment that we do tow off the back of the vessel comes off one of the wires that is connected to the winches below the deck, comes up through the crane, and now through that big block on the top there. So we use that A-frame. It actually can articulate all the way forward and all the way back to help us bring equipment back on or put it out to sea.
And what kind of equipment are we towing behind the ship?
That's a good question. We have a lot of good equipment that we use. We have the tri-axis, the continuous plankton recorder, amongst other
favourites.
It is one of your favorites. And also other equipment of that nature.
Okay, and I guess we need to, you might kind of think, well, why are we towing stuff behind the ship? We're trying to obviously sample the marine environment, and by towing stuff behind the ship, obviously that means that we can sample it continuously as we're moving along. And it also means that we can collect samples from a long way behind the ship. So we're trying to get samples from an undisturbed environment. So, there might be limited value in taking a sample just down there off the side of the ship. If the ship's, cruising along and we're making a lot of wake and disturbing everything, we want to get some of that equipment maybe 4 or 5 kilometres behind the ship, so that it's kind of the ocean settled down, so that what we're sampling is kind of reflective of the ocean in its natural state. If we spin around, we might just walk back a little bit and spin around, because David mentioned the winches, and they're a pretty important part of what we do on board. And we can see the winches set up behind us here, David. So what type of winches do we have, and what do we use them for?
Sure. We have all the scientific winches that are used for the towing are actually down below. But we do have general purpose utility winches that are up here to help us move equipment on the deck and set up for any type of deployments. What you can see in the middle of the pedestal, the sheaves that have the wires coming off, the wires and cables coming off, leading up from down below.
And everything's stored down below. Is that just to get them out of the way, out of the weather?
To get that out of the way, out of the weather, and it actually prolongs the life of the winches themselves and maintains its accuracy and scientific readiness.
Okay, and how far, if we were to tow something like the continuous plankton recorder behind the ship, how far could we tow it on one of those winches?
At least up to 5,000 metres. 5,000
metres, so it's a fair way behind the vessel then. And you can imagine, if you tune in tomorrow, we're going to be having a tour at the same time. We'll pop down to the winch room, and you actually just see the size of 5 kilometres of cable. You can probably imagine your garden hose that you have in your backyard, which is probably 30 metres. That takes up, something the size of a tyre. You can imagine 5,000 metres of cable.
That's a very large garden hose.
It's a huge area that we have to store that. But also behind us too, further up above the winches, there's a drum there which is empty at the moment. That's our net drum. What are we using the net drum for?
It's used for the trawling operations, to actually gather up the net in the actual event when we're deploying and capturing the net.
Yeah, so when we're doing things like scientific trawling to try and understand fisheries, for example. So we've done a number of voyages recently where we've basically gone back to areas that were previously heavily fished, in the 60s and 70s and the 80s, and we've kind of used similar methods to try and sample that environment to see, now that fishing has either stopped or been had tighter controls placed on it, how long is it taking those marine environments to recover from that? And basically doing deep sea trawling is one way that we can do that. We've also got deep sea cameras that we can put down that are much less intrusive, so we can fly them above the sea floor, a couple of metres above the sea floor, and take high resolution video of what the sea floor looks like. We've also got behind us apart from the A-frame, we've got some smaller cranes as well. So these are utility cranes. What are we using these types of things for?
Well, this utility crane is actually very new to the vessel itself. It was put in on board during our dry dock period in Singapore. And not only does it provide logistic support for the vessel, but it also assists in the deployment of our deep core.
Okay, and speaking of new stuff, we're going to pop down here and have a look at something that is brand new to the ship and is really exciting because it's going to really increase the capabilities, particularly in the marine geosciences, so looking at the sea floor, and that is our deep core system here. So we've got the core handler here.
That's correct.
And how does this thing operate?
So the deep core handler crane itself is actually connected to the cradle, and the cradle itself sits alongside the rail here for 24 meters and actually holds the core inside of it. So what this crane does is actually pick up the cradle, put it into the water, so our coring boom can actually move the core into position to free fall to the seafloor.
So this handler is picking up a 24 meter long frame, is that correct?
Frame, that's correct.
And then we're spinning it from horizontal up to vertical and then putting it down into the water column.
That's correct.
Okay, so we haven't really seen that been deployed at sea yet, so it must be quite a sight. So
especially when it's an assistant by the crane itself.
Yeah,
so having two cranes in concert, moving it into position.
And when we say deep coring, we're talking about trying to collect samples of the sediment, so the deep sea sediment, and that is obviously important for understanding geological history because obviously the seafloor is built up in layers over time, and the deeper the core, the further back in time that we can go to try and understand some of the geological and the climate history. And with this system, we can collect cores. How long are we expecting we might be able to collect cores for? How deep?
And we're hoping to do the length of the core itself.
Of the core, yeah. The length, so the 24 metres.
Yes.
That's pretty cool. And then depending on the sediment, that might get us back tens of thousands of years in geological time. And we should be able to do that in most of the deep ocean, deploying that equipment.
Most of the deep ocean, yeah.
Okay, that's quite excellent. What we might do now is we might wander around into the sheltered science area and finish off with a few more of your questions and go from there. So we have had a couple of questions come through as we've been chatting away. One of them has been around how much rope do we have on board, and how often do we have to do maintenance or replace that rope? So let's say rope or winches.
That's right. Look, that's a good question. And I wouldn't even begin to hazard a guess as to how much rope or how much wire is actually on board the ship. There is a fair bit. But we do have enough rope for all of our mooring activities, for emergency towing. And then we have all of our cables and wires for every single one of our winches. And some of them even go to 8,000 meters. They're all under a rigorous maintenance program to ensure that they are capable and ready to use in any condition.
Okay, so yeah, there must be a fair bit of work on trying to maintain some of that equipment. We've had another question come through, which was, I guess, similar to interesting things that we found on the seafloor, which was, is there anything scary, like the Kraken in the deep ocean? I'm not sure about the Kraken, but there certainly is some scary things. So we're talking about some of those interesting deep sea creatures before. Some of the predatory fish and so on have enormous teeth, and they can be quite intimidating. Shipwrecks and so on is something that we have discovered, and it can be quite, I don't know about scary, but it can be quite moving to map a shipwreck when it's been missing. We've mapped a number of shipwrecks that were sunk during World War II, for example, and the whereabouts of those have been unknown for 60 or 70 years. So it's been kind of interesting and quite nice to, I guess, be able to find where they are and I guess give some closure to the families of whose people who loved ones were lost on those vessels. I think for me, some of the scariest stuff is just how much our impact on the oceans we're having. So people think of the deep ocean as often being pristine and untouched. We found rubbish in the deep ocean when we're deploying our camera systems, for example. So beer cans at 4,000 metres deep. We've even found tins of paint, with paint probably still in them, on the seafloor as well, and that can be hundreds of kilometres offshore, so a fair distance away. So we certainly are having an impact on the deep ocean, and things like rubbish are something that we do constantly see as we're cruising along. Particularly the folks up in the observation deck will record the rubbish, so we're starting to build up a bit of a map of hotspots of marine debris around the Australian coastline. But yeah, we are certainly having an impact on the deep oceans. One of the questions that I will ask now, we're actually going to, if you tune in tomorrow, we're actually going to go and have a look at these. And these are our drop keels, which are basically, they extend below the hull of the ship and enable us to deploy equipment below the hull. One of the questions has come through from Nigel around when we have those drop keels out, how does that impact the sailing of the ship?
Yeah. Well, I don't want to give away too much because we should be tuning in tomorrow for the next one. But yes, we can't actually go full speed when we have the drop keels fully deployed. We can maintain our cruising speed of 11 knots, but there are factors, weather factors, and also structural factors on having them below in the water while we're going at speed.
Now, how far down can we extend those below the ship?
Extend to 4 meters.
4 meters below. Okay, so we will actually go and have a look at those tomorrow if you tune in at the same time. So they're pretty interesting, and not many ships have something like that on board. So that's all of our questions that we've had come through for today. So thank you very much for tuning in. The video of today's tour is going to stay on the CSIRO Facebook page, so if you want to have a look at it again or send it on to family and friends, just tell them to go to the CSIRO Facebook page. You can also jump on the CSIRO website too. There's more information about the ship and the kind of work that we do. We've actually got a interactive virtual tour there where you can show yourself around the ship in much more detail, get to all of the spaces that we haven't been able to get to today, and you can also get updates about our voyages and tune into the live stream when the ship's at sea too to find out what we've been doing. So thank you very much for your time, and with that, we'll say goodbye from Investigator.